So it's recording now?
Yeah.
And yeah, so this is lab 6 and I am Junjun and now do the comparison part. Share my screen. Yeah, this is the local version of using CPU in my Mac OS. So I have compiled it yet. uh, as we can see, and I will try first test 512 version. Input is 5, and we can see there are 0.5 seconds, and let me try 10 uh, input, different input. As we can see, there are like 4 seconds, and I will try the largest one. As we can see, we spent around like uh, uh, 550 seconds using local CPU. And now I'm turned to uh, using cloud, and yeah, this is cloud terminal, and as we can see, we have all the document here, and or like CU document is compiled. Let's try the naive one first. First try the smallest version. 5, yes, smallest one. As we can see, we using just uh 1 microsecond, and I will try the uh different different input. Mm, it's natural, and it's like 9 microsoft second, and try the latest one, latest one. As we can see, it's like around 75 microsecond. Uh, yeah, let's try a different one, a different like optimized uh optimized like GPU version. Uh, as we can see, we are using matrix GPU tiled, and the smallest one first. Yeah, as we can see, we are using nest time comparing to the naive one, like 0.7 uh, microseconds. And let's try the uh, different input. It's also optimized like 5 Microsoft second. Largest one. Yeah. Also save a lot of time compared to naive one. So the last one is using a CUDA library. It's to do the matrix product. I will do this version. Let me see. Using this compiled file. First is 5. It's using like 0.9 microsecond and different input. 1.6 and finally 6.7. Yeah, that's the comparison part. So I will stop now and pass to Troy. Yeah, Yichen, right?
Did you run the collab.python?
No. Yeah.
I will run that. Fine, just idols.
Okay.
Okay, so I will just run it on local. So we have the naive CUDA and the optimized CUDA on local as well. Because I got a GPU. And here we can see that the runtime it is fast, but it is slower compared to the cloud. And then over here we have the Python file. That is the Python library with the cuBLAS. So over here we see it's much faster. And over here we have our graphs compared local and on the cloud. So we see that cloud is much faster. Local, um, the naive CUDA and the optimized CUDA is still slower, but over here on the cloud we see it's much fast, and we can also see an overlap between the cuBLAS and the optimized CUDA over here, and the GP and the CPU is much slower in both. Now we'll go to part two, where I will show it on local, and then Dio will show it on the cloud, and then he will talk about the comparison and our outputs. So this is, oh, sorry. So first, I'll be using Laplace. So we have a output. We have a banana PNG over here. Um, that's this one, and we are gonna run it for Laplace. So we can see it takes quite some time on the local device. Over here we can see the outputs for GPU and CPU. It's the same output. Uh, and over here we have the time comparison for CPU and GPU as well. So we can see the GPU is much faster. And now we'll use the Sobel. So Sobel is much faster in terms for Laplace. And over here we have the output for the GPU and the CPU. And now Dio, sorry.
Yeah.
Yeah. Now Dio will take over and show on cloud.
Can you see it?
Yeah.
Okay, cool. So I'll show the run output for clouds and here. So basically, we are using some classic filters like Laplacian and Sobel and someone else, but here I only show the two different filters, one for Laplacian and one for Sobel. First I should compare it and run the Python field for the banana.png. So the number three show me it where the model we're using is Laplacian. And here our code includes the C code and for CPU and the code output. It also takes like 20 seconds
Yeah.
for CPU. Yeah, it's 25 seconds, and you can see the GPU convolution time in 0.4 second. It's a bit slower than Rose Rose laptop.
Yeah.
Yeah, because she might have a better GPU than Tesla T4. And I'll first run the command and then show the output image. Yeah, so about skipping the CPU convolution and the GPU convolution is also about 0.4 second. And we also support the different image format like .jpg. Yeah, because the parrot image size is much smaller than the banana, you can see here. So for the CPU convolution time, it's decreased by 10 times. So the image size is about 10 times smaller. And also here, yeah, you can see the so-called GPU convolution time for the parallel.gpg is 0.4 seconds. And I have nothing to show. We also do the different format of image. We convert the GPG field to the grayscale image. And basically they are giving the same result. It's not make big difference. And we can download the output file directly from the SSH in browser from Google Cloud. I just random download a smaller one. No such field, but it's
Maybe there's a space after PNG. The space after PNG. Just try to download it again.
Space.
Yeah.
Oh, I mistakenly add a space. So one good reason for we choosing Google Clouds is that we can directly download the files from the VM, and here. This one is the age detected results by Sobel, and we also have this one is Laplace. And also for the parrot, we got, yeah, this one is for Sobel, and this one is for Laplace. Um, do you have anything else?
Yeah, I think that's it.
Yeah, I think. And here's our integrated code in our shared library, and we expose these functions to Python and just on the Python files, which make it easier to access. That's all for our lab 6. Sorry. Thank you.